Now we are talking about the work-energy theorem. The work-energy theorem. It said the work done by the net force of an object equals to the change in its kinetic energy. So meaning that we can get the work done of an object or a body by just finding the change in its kinetic energy. So the final kinetic energy minus the initial kinetic energy. So this is a work-energy theorem. So it's telling us that we can easily get our work done by finding change in the kinetic energy. Note, why do we actually see this formula to be an interesting thing? So it's a formula that connects the force, motion, and energy without needing time. So it makes us to calculate our work done easily. So from there we now move to the next part. We said work, energy, and power. So we're talking about power. Power is defined as the rate of doing work. The rate of doing work. So that means it has to involve what we call time when we hear the word rate. So power is equals to the work done over time. So where our W is equals to the work done and our T is equals to the time. And we can also write this power as force times distance over time. Note, our work is equals to force times distance. So that means we can write it where our F is equals to the force, our S is equals to the distance. And we already know that our F can be equals to mg. So our S is also the same thing as our height. So they are both distance. So that means we can write the formula as mgh over t, where our S is distance, our g is acceleration due to gravity, our h is what? The height or the distance. And our m is equals to the mass. And this can also be written as Fv, which is force times velocity. How do you get about this? Our mg is equals to the F. Our h over t, like distance over time, will give us the velocity. So that means we can write power as Fv. You can see these are different ways we can use in writing power. These are different formulas for solving powers. Now let's talk about the unit of power. The unit of power is what? Is watt. So the unit of power is watt, like that of energy and work is joule. That of power is watt, and watt is same thing as, so like we said, 1 watt is equals to 1 joule per seconds. So it's same thing as joule per seconds. It's joule per seconds. Now let's talk about the larger unit in larger quantity, where we have 1 horsepower is equals to 746 watts. So when you be hearing this thing, horsepower. So 1 horsepower is equals to 746 watts. So from there we talk about the law of conservation of energy. So law of conservation of energy, which says that energy cannot be what? Created nor destroyed, but can be transformed from one form to another. So we can easily see an example of this because it's very, very common around us. You having an electric iron plugged in. So the electric iron is converting the electrical energy into a thermal energy or heat energy. So, and we have so many examples of this also. So you having your television or your radio that is converting the electric energy into a what? A sound energy. So you can see converting it into different type of energy. So it's transforming it. So that's confirming this law of conservation of energy. So total energy in an isolated system remain constant. This is a note. Note that the total energy in an isolated system will remain constant, meaning that the potential energy plus the kinetic energy is equals to constant. Example of this, we have a free falling body. A free falling body continuously converting potential energy into kinetic energy, because each thing before is in potential, is having potential energy. Now falling down, potential energy is now being transformed or converted to a kinetic energy. Now let's go to some real life application of this. Real life application. There's application in real life. Machines, engines, and electrical generations. In all these places, we use this work, energy, and power. Because you yourself are talking about the power of this machine is equals to this. The energy this machine has done, the work this machine has done. Even in electric generation also, all this turbine. So they will tell you the power it can generate at a time. And even in that process is using power and is generating power. Okay, so we have roller coaster, energy transformation also. We have power plants and moving vehicles. So vehicle moving is converting chemical energy into mechanical energy, because the chemical energy is getting from the what? Petrol. Type of fuel is using. They are the petrol or the diesel, depending on the type of the engine you're having. Maybe this is a petrol base or a diesel base. This and more about engineering courses. So depending on the type of fuel is using, so we can still classify it as maybe is still converting energy also from that of petrol or diesel, is converting from chemical energy to a what? To a mechanical energy through the wheels. So it's converting it to the mechanical energy theories. So these make physics more interesting, because you later see this application probably for people that goes for engineering course. We later see more about this application. So it has great application in the real life.